2025 A-Level Combined Mathematics Paper 2 Part B question number 15 Part A. Part B of this same question will be discussed in a future video, link in the top right. Part A of this question has to do with uniform straight rods and their interactions in a system of forces. The question says, three uniform rods AB, BC and CD of equal lengths of 4A and weights of W, 2W and W respectively are smoothly jointed at the endpoints of B and C, and the end A is smoothly hinged to a fixed point, and one end of a light inextensible string is attached to the joint B, and the other end of the string is attached to a point lying vertically above B on horizontal ceiling. Now, given this, they say the three rods are kept in equilibrium in a vertical plane by placing the rod BC on a smooth fixed peg at the point E where BE length is 3A, and by applying horizontal force of magnitude P at the point D such that the string is taut and each of the rods AB and CD is making an angle of 60 degrees with the vertical and the rod BC is making an angle of 30 degrees with the vertical as shown in the figure. Now, taking a look at the figure, we can see most of the information given here is marked except for the forces. We can see we're missing the weight of the rod AB, it's going to be like this. We're missing the rod BC's weight, which is going to be like this. We're missing the rod CD's weight, which is going to be like this. We're also missing the tension in the string up here. We're missing the normal reaction on the rod by the peg at the point here. And we're also missing the force on the rod AB by the fixed point A. So it could be in any direction here. Let's suppose it's in this direction. We are missing all of these forces. Now, due to this, before even looking at the questions asked, let's draw another diagram and fill in all of these forces. So going down, I've drawn a diagram, and what we're going to be doing is to fill in all of the forces and any other information that we see fit into this diagram. The reason for this is that if we have all of the information, then when we're answering the questions, we can more easily look at this diagram and solve the questions. So given this diagram, we can see the rod AB has a weight of W, and since the rod AB is uniform, that weight is going to act at the center of the rod. So therefore, if the total length of the rod is 4A, then the weight W is going to act at the center, which is somewhere over here. It's going to act vertically downward, and the length from here to here is going to be 2A, and the length from here to here is also going to be 2A. Now, considering the next part, at the point B, there's a string attached, and that string has a tension of T. So I'm going to draw the tension upward like this as T, and also on the ceiling, there's the same force of T downward, but in this case, since the ceiling is fixed, we don't really care about it. So I don't actually need to draw this tension. I can do it if I want to, but I don't really have to. Now, moving on, the next force we're going to mark is the force that's going to be on the rod BC due to gravity, which is the weight W downward, which is going to be again at the center point of the rod. So it's going to be over here, let's say, downward of 2W, and also the length here is going to be 2A, and furthermore, since the length from B to E is 3A, we know that this length here must be equal to A, and also this length here must also be equal to A. Now, after that, at the point E, the peg at E is applying a normal reaction on the rod BC, and due to that, I'm going to mark the normal reaction like this, and I'm going to call it, let's say, R, and I'm also going to mark a 90-degree angle here to indicate that it's normal. Now, additional to this, we also have the weight of the rod CD, which I'm going to mark at the center point of CD, vertical downward like this, and this weight is W. And I'm going to mark the length here, this is 2A, and this is also 2A. Now, additional to this, at the point A, since A is hinged, there can be some force at the point A on the rod AB. So I'm going to mark it in, let's say, this direction right here, and I'm going to call it, let's say, R dash. Now, as it turns out, when we solve this question, we will not actually have to ever consider R dash, because of the reason is that we are going to solve this question in a clever way, in which case we will never have to take a look at R dash, but for now we're going to mark it. So now we have the entirety of the system of forces that we have in this question. So let's go up and finally read the questions that were asked. We are first asked to find the value of the force P. So this horizontal force P, we need to find its value. Now after that, we are asked to show that the magnitude of the reaction on the rod BC from the peg is W over 3. So basically from the peg at the point E, the reaction at the point E is going to be W over 3. And finally, we are asked to show that the tension of the string is a certain value. We are asked to find it. Now, in this question, we are asked to find the value of P and find the value of T, or the tension, but we are not asked to find the value of R. We are instead asked to show that it's equal to W over 3. Now, this doesn't really make much of a difference, but we know that the correct answer here is W over 3. Now, in these kinds of questions, it's important to know that with this kind of question where you're asked to find a value, you do not know if you've written the correct answer. So if you make a mistake somewhere in the question, you cannot know whether you've gone wrong or not. However, in this question, since they've already given the answer, we know what we're supposed to get, and therefore, if we ever get something wrong, we will know. So due to this, when you're solving this question, you can be a little bit relaxed. But when solving this question and this question, you have to make sure you do everything correct, because otherwise, if you make a mistake, you will not know. Alright, so now let's start off with question number 1. Now to find the value of P, if we consider what we have, in the system of forces we can see the force P acts on the rod CD. So we need to find some equilibrium equations for the rod CD. Now considering rod CD, we can see that there is one force here of P, there's another force of W, and also there's a hidden force that we can't see, which is the force at the point C. You see, since these two rods BC and CD are jointed together at this point, there is going to be a force internally from the rod BC to the rod CD, and an equivalent of this force is going to be applied by the rod CD to the rod BC. So due to this, internally at the joint C, there is actually a force. It could be something like this, we don't really know. There's a force like this, and an equal and opposite force is going to be applied on the other rod BC. Now if we want to resolve this thing and create two equations, we are going to have to include this force here. So due to that, if you try to resolve, you're going to have to always include this force in your equations, and then you're eventually going to have to also find this force. So that's one way. Another way that we could create an equation is to use moments. You see, for the rod CD, if rod CD is in equilibrium, then the moments around any point inside of the rod must be equal to 0. Now considering that, if we do a little bit of a clever thing and we take moments around the point C, we can see, since this unknown force here, the reaction force from BC to CD is traveling through the point C, if we take moments around the point C, we actually don't have to consider this force at all. We can just consider the other forces applied on the rod, which is the force W and the force P. And due to this, we can actually make our work easier by never having to consider this reaction occurring internally at the point C. Now this is actually the intended method for this question, and you will see for the other two parts of the question also we're going to do this exact same thing. There are internal forces here that we're simply going to ignore. So considering the first part, to find the force P, what we're going to do is to consider moments around the point C, because then the internal force applied at the point C by the rod BC on the rod CD is going to be cancelled out. So what we're going to do is to take moments for the rod CD around the point C, and by doing that we can find an equation for P in terms of W. So going down, if we do that, what I'm going to do is to write question number 1, and I'm going to say taking moments about the point C, and we'll say in, let's say, the anticlockwise direction for rod CD. So we're only applying for the equilibrium of the rod CD, which of course the moment should still be equal to 0. Taking moments around the point C for the rod CD, we should have the total moments being equal to 0. And on the left hand side, the moments that we have are the moment due to the force W and the moment due to the force P. Now for W, we can see the angle here is 60 degrees, meaning the distance that we need is this distance right here, and that distance is going to be 2a times the sine of 60. So 2a sine 60. So the moment here in the clockwise direction due to the force W is going to be 2a sine 60 times W. Now as for the other force P, considering the force P, what we need is this vertical distance here, since that's the perpendicular distance for the force P from the point C, and that distance can be found by the fact that the hypotenuse here is going to be equal to 4a, and the angle here is 60 degrees, meaning that this length here is 4a cosine 60. So applying those two, if we go down and write down the moments that we have, in the clockwise direction, we have a W applying its moment in a 2a sine 60 direction. So we have minus 2a sine 60 degrees times W, and a plus because the P is applying the force in the moment rather in the anticlockwise direction of 4a cos 60 P. So we have plus 4a cosine 60 degrees times P. Now from this we can simplify, we get minus 2a times sine of 60, which is root 3 over 2 w, plus, and then we have 4a times cosine of 60 is a half, times p equals 0. Rearranging, we can see on the left hand side, if we keep this part, we have 2ap equal to, and on the right hand side, if we take this, we're going to have minus 2a is going to become plus 2a, so we have plus 2a root 3 over 2 w, and then we can see if we cancel out the 2a and the 2a here, we are going to get that p is equal to root 3 over 2w. So that's our answer. We could easily find the value of P and never have to consider the internal force at the point C. The reason for that is because if we take moments around the point C, then it's all going to cancel out, since at the point C, since the reaction forces here from BC to CD and from CD to BC are traveling through the point C. Now for the next part of the question, they say, show that the magnitude of the reaction on the rod BC from peg is W03. So for this thing, what we're going to do, again, if we consider the point B, from the rod AB to the rod BC, we're going to have internal force is going to be something like this, let's say, and the same exact force is going to act in the opposite direction, equal in opposite direction, like this on the rod AB. Now, if we take moments around the point B, then we will not have to consider this force. So here, we could do two things. If we take moments around B, in order to find R, we could either take moments for the entire rod of BC, or we could do another clever thing and take moments for the entire system of the two rods BC and CD. Now the reason we want to do that is because since at the points it's an equal and opposite reaction here and here, if we consider the entire system, then the internal forces are going to create internal moments that will cancel each other out. And due to that, if we take moments about the point B, not only can we ignore the reactions that are happening through the point B itself, we can also ignore the reactions that are happening through the point C. So again, you can see if we take moments like this in a clever manner, we can eliminate unnecessary factors and get equations much easier. So this is what we're going to do. We can eliminate here the tension T, the reaction through the point B from the rod rather AB, from the rod rather AB to the rod BC, and we can also avoid the reactions at the point C from BC to CD and CD to BC. So going down, what we're going to do is to do exactly that. So going down, if I say question number 2, I'm going to say taking, again similar to this thing, taking moments but this time I'm going to say about the point B, again we'll do anticlockwise direction, and then we're going to say 4, and instead of just any of the rods, like instead of rod CD or BC or something like that, I'm going to say 4 rods BC and CD taken as one object, because if we do that, we can eliminate the internal forces. So now, if we consider the moments around the point, since this whole entire system is in equilibrium, the total should still be equal to 0. So I can write equals 0 on the right hand side. Now for the left hand side, if we consider all the moments involved, we have a 2w in the clockwise direction, so that's negative, we have negative, and considering the distances, here we have this perpendicular distance, which is hypotenuse of 2a and 30 degrees here, so this is going to become 2a sine 30, so we have 2a sine 30 times 2w in the negative direction, so we have negative 2a sine 30 times 2w, and then the next thing we can consider is the r. So the r is perpendicular and it has a distance of 3a here, so we have 3ar directly, so we can say plus 3ar plus 3ar, and then next force here, since we're ignoring internal forces, since we're taking the entire set of rods as being, a single thing, we can ignore the internal force at the point C and directly go to this force here. This force is vertically downward, and considering the distance, the total distance that we need is this entire distance, which is this distance plus this distance. Now this first distance can be found, since the hypotenuse here is 4a and the angle here is 30, this is going to be 4a sine 30. Now the second part, the hypotenuse here is 2a and this angle here is 30, so we have 2a cosine 30 Meaning in total, we have 4a sine 30 plus 2a cosine 30, and we have w in the clockwise direction. Meaning in total, the moment here is negative, brackets, 4a sine 30 plus 2a cosine 30 times w. So going down, if we write that, we have minus 4a sine 30 plus 2a cosine 30 times w. Now finally, we have one last force, the force P here, and considering that force, the distance that we need is the vertical height from here to here, and that height can be broken into two pieces. If we take this height, it is this height plus this height. Now the first height here, this height can be found by the fact that the total distance here, the hypotenuse is 4a, and this is 60 degrees, so we have 4a cosine 60. Now the second part, we have hypotenuse here of 4a, and this time we have 30, so we have 4a cosine 60 plus 4a cosine 30, and P is going to create a moment in the anti-clockwise direction, so we have positive moment, which means in total we have 4a cosine 60 plus 4a cosine 30 times P in the positive direction. So we have plus 4a cosine 30 plus 4a sine 30 times P, and all of that added together is equal to 0. So now given this, we can see we have only a single unknown here, r, since we know P and we know W. So given that, we should be able to use this equation to eventually solve for r. So considering this thing, all we'll have to do is to substitute values into here and simplify. So if I say substituting, we go down, we can see we have minus 2a times sine of 30, which is going to be half, times 2w, and we have plus 3r ar, which I'm going to leave as plus 3ar, and then this part here, we have minus 4a times sine 30 is 4a times half, plus 2a times cosine 30 is going to become 2a times root 3 over 2, and then that's going to be multiplied by w, and then we have plus 4a cosine 30 is going to become 4a times root 3 over 2, plus, and then 4a times sine 30 is going to be 4a times half times P equals 0. Actually, we could substitute P also. P is equal to root 3 over 2w, so we can say root 3 over 2w equals 0. Now simplifying this thing down, what we can do is to take 3ar to one side and take everything else to the other side. So doing so, we can see if we take 3ar to one side, 3ar, we have 3ar equals, this thing taken to the other side is going to become, if we cancel the 2 and the half, we're going to get 2a times w, so 2aw. For the next part, we're going to have 4a times half, which is 2a times w, another 2aw, so plus 2aw. And then this 2a times root 3 over 2 is going to become, cancel root 3aw, so it's going to be plus root 3aw. And then for this bit, if we cancel this thing, and the 4, we're going to get another root 3aw times root 3, which is going to become 3aw because of the root 3 here, of course. So root 3 times root 3 is 3, and then divide by 2, divide by 2, divide by 4 times 4a is going to become just a. So we have plus 3aw. And finally, actually, I made a mistake there. Since it's plus here, when we take it to the other side, it's going to become minus. So we have minus 3aw actually. And then finally, from this 4a and half, we're going to get 2a. 2a times root 3 over 2 is going to become root 3a times w. So we have minus root 3aw. Now simplifying everything down, we can see on the left hand side we have 3ar, and on the right hand side we can see 2aw plus 2aw minus 3aw is going to become just aw, so we have a plus aw, and then plus root 3aw and minus root 3aw cancel, meaning that we get that 3ar is equal to aw, and finally we get that the r is equal to w over 3. So there we go, there's the answer of w over 3. Now going up, we can see, since this particular question had the correct answer, we know that the answer here is in fact correct, which means our method is probably correct, and we got w over 3. Now for P, we don't have the same luxury, but since we use the result of P to find that the r is equal to w over 3, we can be confident that we got P correct as well. So now, let's finally move on to the last part of the question. The last part of the question says, find the tension of the string. Now considering that, we can see once again we have an unknown force r dash at the point A. But if we take moments about the point A, then that force will be cancelled out. And furthermore, since we are going to consider the entire object here as a single object, any and all internal forces will also cancel out. And due to that, if we just take moments for the entire system about the point A, then we don't have to worry about r dash, and also we will directly get an equation that contains all of the other external forces on the system of A, B, C, D. Now considering that, we can see that entire system is going to contain T, which means if we make this equation, we will get T. So what we're going to do finally for the last part is to once again take moments, but this time about the point A, and this time for the entire system. So if we go down and write number 3, question number 3, we're going to say this time taking moments about, and this time we're going to say about the point A, again in the anticlockwise direction by convention, and we're going to say for the system. So we're going to take it for the entire system, and we'll say something like A, B, C, D, since that's the entire system that we're considering. Now, since the entire system here is under equilibrium, the total moments must be equal to 0. Going up, if we take a look at the total moments, for this one I'm not going to do much explaining, I'm just going to show you the distances and I'm going to write down the moments. The first moment, if we take, let's say, we go from left to right, the first force we find is W. W is downward, so clockwise moment. Distance here is this, which is, if we take a look, 60 degrees, 2a sine 60 times W. So we have a minus 2a sine 60 W. Going down, minus 2a sine 60 times W. Now considering the next force from left to right is the force of T. The force of T is upward, meaning we have an anticlockwise moment, so the moment is positive. The distance here is 4a sine 60, so we have 4a sine 60 t. So plus 4a sine 60 t plus 4a sine 60 times t. Now the next moment that we have is this force right here, 2w downward. The distance relevant is this distance, which can be broken into two parts, this part and this part. This distance is 4a sine 60, and this distance here is 2a sine 30. So the total distance is 4a sine 60 plus 2a sine 30. And since the moment is downward, it's going to be negative since it's clockwise, and therefore the moment we're going to get is 4a sine 60 plus 2a sine 30 times w, negative 4a sine 60 plus 2a sine 30 times 2w, negative. Now going up, the next force after that is the force of r here. Now for r, to find the perpendicular distance is actually quite easy, since if you take a look, the angle here is 90 degrees. Since this is 60 degrees and this is 30 degrees, the angle here is 90 degrees. Now since this angle is also 90 degrees, this line, the line of action of R and AB, are actually parallel to each other. And due to that, the distance that we want is actually this distance, which is 2a plus a, or 3a. So therefore the moment here is 3a r, and considering the distance here, since it is on this side, it is anticlockwise, and therefore the moment is positive. So we have plus 3a times r, so plus 3ar moment. So going down, plus 3ar. Now going rightward, the next moment we find is the moment, well, there's no forces through the point C, since that's internal forces, meaning the next thing we have, well, not no forces, rather I should say there's no net moments through the point C, since both of them are internal. And next we have W. For W, the distance relevant is that distance from here to here, which can be broken into three pieces. The first piece is this piece, the second is this piece, and the third is this piece. The first piece is 4a sine 60, the second piece is 4a sine 30, and the third piece is 2a sine 60. So all in all, we have, if we go down, 4a sine 60, 4a sine 30, and 2a sine 30. And since in the clockwise direction, we're going to have a negative moment. So we have negative, if we go down, we have negative 4a sine 60 plus 4a sine 30 plus 2a sine 60 times w, and that's negative. Now finally, the last force that we have in the system is the force P, and considering the force P is all the way down here, meaning we need the vertical height difference, and if we go leftward like this, we can see the height we need is this height. Considering that height, in order to get there, we could go from this level up to here, which is 4a cosine 60, and then go from that level up to this level, which is 4a cosine 30, and then go down to this level, which is 4a cosine 60. So therefore we have to go up by 4a cosine 60, up by another 4a cosine 30, and then down by 4a cosine 60. So therefore the total height difference relevant there is 4a cosine 60 plus 4a cosine 30 minus 4a cosine 60. And then, since this force is down here, it has an anticlockwise moment, meaning that the moment is positive. So going down, if we write that, we have plus, and I have to be careful here, we have plus 4a cosine 60 plus 4a cosine 30 minus 4a cosine 60 times p, and that is equal to 0. So now we have this equation. Considering this equation, we can see we have r in it, we have p in it, and we have w in it, and we also have t in it. Now since we already know r and p and we are taking w as known, we will be able to find t using this equation. So all we have to do now is to substitute and simplify. So if we do that, if we say down here substituting and simplifying, what we can do is to substitute all of the trig values and the value of r and the value of p. So if we do that, the first term becomes minus 2a times root 3 over 2 times w. The second term becomes plus 4a times root 3 over 2 root 3 over 2 times t. The next term becomes minus 4a times root 3 over 2 plus 2a times a half times 2w. The next term becomes 3ar, but r is equal to w over 3. So substituting, we have 3a times w over 3, which is going to become aw. So plus aw, and then we have minus 4a times root 3 over 2 plus 4a times 1 over 2 plus 2a times root 3 over 2 times w. And then finally in the last line we have 4a times a half plus 4a times root 3 over 2 minus 4a times a half, 4a times a half times p, which we found p to be equal to root 3 over 2. So we can substitute into there and write that this is equal to root 3 over 2. So we have root 3 over 2 times w, and that is all equal to 0. Now finally, what we can do is to take t to one side and simplify everything else down. Now since every single one of these terms has a in them, what we can do is to divide everything by a. If we do that and we take everything except for the t term here to the other side, what we're going to get on the left hand side is going to become 4 times root 3 over 2t, or 2 root 3t, 2 root 3t. And if we take everything else to the other side, starting from this term, we're going to have 2 divided by 2, which is just going to be 1 times root 3 times w, so root 3w. Since it's minus, when it gets taken to the other side, it's going to become plus, so we have plus root 3w. And then the next term after this is going to become this term. Since it's negative, when it gets taken to the other side, it's going to become positive. We have 4a times root 3 over 2. Cancelling this to this, we have just 2 root 3 times 2w, which is going to become plus 4 root 3 w on the other side. So plus 4 root 3w. The next term here is just 1, and taking that times 2w, we have just plus 2w on the other side, so plus 2w. The next term after that is plus aw, which when taken to the other side becomes minus w. And then this thing is all minus, so when we take it to the other side, it's going to become plus. We have 4a times root 3 over 2, cancelling out, we have 2 root 3 times w, so plus 2 root 3w, and then 4 times a half is going to become 2 times w is 2w, so plus 2w, and then 2a times root 3 over 2 is going to become just root 3 times w plus root 3w. Now for the last term, 4a times half is 2a times root 3 over 2 is going to become root 3 times w is going to become plus root 3w. Since it's plus, when it is taken to the other side, it's going to become minus. So we have minus root 3w. The next term here is going to become 4a and 2 is going to cancel to give us 2 root 3. 2 root 3 times root 3 over 2 is going to become 3w. Since that's positive, when it gets taken to the other side, it's going to become minus 3. So we have minus 3w. And finally, the minus here is going to become plus. We have 2 times root 3 over 2 is going to become root 3. So we have plus root 3w. And that is it. So finally, all we have to do now is to simplify this mess down. And if we do that, we have 2 root 3 t on the left hand side. On the right hand side, we have 2w minus w is w, and 2w minus, okay, it's going to cancel. Everything cancels here. So the 2w, and minus w minus 3w cancel to give us 0, and everything else is going to become minus, well, this thing also cancels, minus 3 root 3, minus root 3w, and plus root 3w cancels, leaving us with just root 3w plus 4 root 3w plus 2 root 3w plus root 3w, which is going to be a total of 8 root 3w. So we have 8 root 3w, and if we divide everything by 2 root 3, we finally get that t is equal to 4w. T equals 4w. And that is going to be the final answer for this question and the final answer for the entire question 15a. So now I know it had some messy things in it. It had some, like this whole huge bundle of, surds and negatives, positives, w's, a's, all of that, and all of this that we have to simplify. But if you really think about it, all we had here was the sine of 60, the sine of 30, the cosine of 30, and the cosine of 60, and a bunch of algebraic simplification. There was nothing complicated in here. The only special thing that we had in this question was the fact that if we take moments for only specific sections of the entire system through specific points through which there are internal forces, and if we treat whole sections of the system as single objects, then we can vastly simplify our calculations when we're taking moments. That's the only special thing we had in this question. Now, due to this question is actually quite easy in my opinion. So now that we've solved the entire question and solved all of this huge mess that we had here, let's finally discuss the marks awarded for this question. So at the start of the question, for the first part, when you find the equation by taking moments about the point C for the rod CD and you write down this equation right here, you get 10 marks. When you then simplify it down to get that P is equal to root 3 over 2W, you get another 5 marks. For the second part of the question, when you take moments about the point B for the rods BC and CD taken as one single object and you write down the entire moment equation like this, you get a total of 15 marks for that equation. When you then substitute in the values from the previous question and also the sine values and cosine values like this, you get another 5 marks. And when you get the final answer of R equals W over 3, you get another 5 marks. Now for the final part of the question, when you take moments about A for the entire system and you write down this absolutely monstrous three lines, this 3-line equation of all the moments, and you write it's equal to 0, you get a full 20 marks. Now after that, when you substitute and simplify and get this thing right here, you get another 5 marks. And when you obtain the final answer of T equals 4W, you get a final 5 marks. And that is going to be all for this question. So I hope you enjoyed. If you have any feedback, post them in the comments down below. Thank you for watching and goodbye.